Today we are going to start you a example series about the Pytorch implementation in neural network or the convolutional neural network or the machine learning projects. Okay, what's the Pytorch? Pytorch is a subversion of the machine learning library. It's built by the Facebook. It's on the Facebook. It's different from the TensorFlow. TensorFlow is the easiest way to build the machine learning models in neural network applications. But in the Pytorch, we can optimize or we can build some complex structure by utilizing the Python programming language features. Okay. For example, the class implementation or the derivation of the some class based on the Torch library. Okay, do you understand that? So the Facebook built or established this library, and then we will get some 5 examples related to this project. Firstly, we need to implement the linear regression model utilizing the Torch library. And after that, we will build the binary classifier and also the CNN application. And after that, we need to create some neural ordinary differential equation in order to what? In order to get the system dynamics model in the neural network application. Okay, these are the useful topics. But firstly, I will explain how you can use the Pytorch and the Torch library in order to build the neural network models. Okay, this is the different from the TensorFlow. TensorFlow is the more easier than the Pytorch implementation. Okay, but the TensorFlow has an advantage of the graphical visualization of your codes or the outputs. But in the Pytorch, we don't have the more options like the TensorFlow. Okay, so in the first example, we need to give the linear regression .py in here. So in the first place, we need to import the Torch library. In order to use the Torch library, you need to install by using the pip implementation. Pip install the Torch or Torch Vision application. You can check the internet in order to learn how to build your model or install the Pytorch model in your computer. Okay, this is not a default application like the TensorFlow. You need to install all the variable. In the Torch library, we have some basic parameters like this one, the Torch NN. NN is the basic building library to build the neural network structure. For example, we can add some neurons or the hidden layers or the output layers by using the NN. Okay, and also we can give the Torch Optim library as the Optim. This the solver design for your neural network application. Okay, and also we need to give the NumPy as MP for matrix operation or the array operation in your code. And also we need to give the matplotlib pyplot to visualize all the results coming from this linear regression model. Okay, as always we do firstly we need to generate the dataset in here like this one. MP random seed function can be given in here, and x can be assigned with the MP random rand function with the dimension of the 100 times 1. This is a vector to get the input values of our study. Okay, and so the output can be defined with the 2 times x plus 1 plus 0.1 times MP random rand n 101. Okay, so this is some kind of noise which is given in here, and we add the bias value and we add the linear value. Okay, y is equal to 2x, and so this is a linear regression. But in order to be forced the signal to be noised in this case, And so we need to add this implementation. Okay, you get it? Any question? You have question? Okay. So in the second step we need to convert the whole the terms to this data. This data to what? To tensors. In Pytorch, we need to use the torch tensor, which means that the torch tensor is a specialized data set or the variable type. In order to what? In order to be utilized in the Pytorch library. Okay? You should always convert the whole the terms into the what? Into the torch one. Okay? And so the x can be assigned with the what? The torch. We have the tensor function in here, like this one, and x given with the what? D type, torch, float, 32. Okay? And also we need to give the y with the what? This term. Okay? If you don't do this, and you will get the error. Okay? So start the notation in here like this one, and then we need to create the what? Create the linear model. Instead of using the sum prepared function in the Pytorch, we need to build the sum classes in order to build the what? The neural network, but with basic one difference, which means that we can create the linear regression, it's the name, but we need to drive this class with the what? NN module. Okay? This NN module is given in the what? In the torch library. Okay? And so if we drive the linear regression by using these terms, and then we will have all the features, properties, methods, or the functions to be used in this linear regression model. Okay? So we need to give the constructor of this term like this one with the parameters of the self, and also we need to give the super function. What's the super function? Do you know it? Do you know it? The super function means that super function directly calls to the what? The base class properties. If we have the derivation or the inheritance property like this one, NM module, we need to call the constructor of this module in order to get the whole the features, properties, or of the methods or the methods. Okay? And so if we don't have this kind of constructor calling, and then we will get error, because we need to build whole the NM module in the linear regression one. Okay? In the TensorFlow we don't need to do that, but in Pytorch we need to implement this structure. Okay? And so the self linear is a new variable in here with the parameters of what? The linear neuron 1 and 1, which means that we have one neuron in here, and so this linear neuron is assigned to the what? The self dot linear. Self is the what? Is the parameter or the instance value or internal values of this class instance, which means that this self possesses all the features of the linear regression, and then we can create the what? The self linear with the parameters of the what? NN linear function, and then we can build the what? The neuron and one neuron. Okay? This is the constructor of our algorithm, and also we need to give the forward terms or function in here like this one, self and x. This is what? This is created the structure of your neural network, which means that we need to return to the what? The self linear function with the input values of the x. And so in the definition of the forward, if we have this function, and then this linear regression can be called by using the forward function. Okay? And so this forward returns to the what? The structure of the neural network. Okay? In the next application, we will derive some other parameters in here, like this one. And so this linear is indicating to the what? The NN linear neuron. And so this self linear gets the point of the x, the input values, and returns to the what? To the outputs of the linear neuron. Okay? You get it? You get it? Do you understand what I'm saying? Okay. It seems you are so confused about the lessons. I'm sorry about that. No, not you. So, how can we create the model? In order to create the model, we need to call the constructor of the linear regression one. Okay? And so this model can be created what? The linear regression constructor. Okay? And so if I call this function, and then this model gets the properties of the init and the forward function. Okay? So in the next case, we need to define the loss and optimizer functions. Okay? Firstly, we need to give the criterion in here, like this one, and then MSE loss, mean squared error loss, is assigned to the what? The criterion. Okay? And then we need to give the optimizer function in here, like this one, the optim SGD, which means that stochastic gradient descent algorithm. Or we can use the Adam optimizer. But in this case, I choose the stochastic gradient descent. With the what? With the model parameters. Like this one. Where is it come from? These parameters. We don't have any function in here. Yes. And we need to give the other parameters, LR. What's the meaning of LR? Yes. Stochastic gradient. Okay. After that, we need to train the model by using these terms. Okay? So, firstly, we need to give the number of epochs in here, num epoch 1000, and for epoch in range what num epoch in here. Firstly, we need to give the what, the output value, or we need to obtain the forward values in here, like this one. The outputs is equal to the what, the model, which is given with what, x. X is our input. Okay, and so this model generates the instantaneous outputs of your neural network. Okay, and after that, loss can be created with the what, the criterion function, because it's equal to the what, the MSE loss, right? And so we need to give the outputs and the target set y. Okay, and so we get the loss function or loss value. What's the purpose of the calculating the loss in here? Yes, if we have any loss in here, like this one, and then we will train our network, or we update the coefficients of your neural network, right? Okay, so after that we can propagate error by using the what? Firstly, in the Pytorch application, we firstly remove or reset to the what, the whole the coefficients in here. But this is the delta coefficients, okay? Not the real coefficients. Delta coefficients should be equalized to 0, or the resets, okay? And after that, loss function can be given with the backward term in here, like this one. We propagate in a backward way in all the functions, and after that, this optimizer should be called with the step. In order to what? In order to get the next step in here. This is the calculation of the loss backward coefficients, the delta terms, and so this optimizer steps is assigned to the new coefficients, and then next process is done. Okay? So at each step we can visualize or print the whole results like this one. Percentage 100 is equal to 0, which means that at each 100 steps we get the what? This term, like this one. F epoch plus 1 divided by total epoch, okay, num epoch, and we will give the loss like this one, loss items, item, okay. And so for F, this is the floating point number of our algorithm. So this is the training phase of our algorithm. After that we need to plot the whole results in here. Firstly, we need to predict values of this one. The model has the what? The train coefficients in here, and X should be given. And we have the detach function. Detach function means that this produces the what output values into the what? Into the tensor form. And also we need to get the numpy function in here to what? To get the scalar values of the whole the terms. Okay? This is just what the properties of the Pytorch library. If you are using the Pytorch library, we need to convert the whole the data by using these codes. Okay? So the model X can be given in here, and PLT scatter can be assigned. This one X we need to convert to numpy function, Y numpy function like this one. This is the smallest Y, okay. This is the Pytorch library. Yes, okay. And after that we can label all the data like this one, the original data, and we can plot this data X numpy predicted values, and label is assigned with what? Fitted line, okay, the color of red. PLT legend, PLT show, okay. And so these are the model, and if you run this code we will get this line, okay. Or we can increase the epoch number in here. The error is smaller and smaller at each time, but never goes to 0 because this is a linear model. There could be always a small error in here, okay. This is the baseline of the what? Of our prediction. Any question? Any question? Okay. So this is the first example of the Pytorch application. And after that we will move to the binary classifier using the what? Pytorch, okay. So in order to implement this term we need to get the Pytorch library in here, and we need to implement the Pytorch NN as NN, okay. Import Pytorch optim as optim, and import numpy as np, and import matplotlib pyplot as plt, okay. What's the purpose of the S in here? Do you know that? Yes, yes. This is the identifier of the torch NN, right? So, firstly, as always we do, the generate random dataset. Okay? MP random seed values is assigned to 0, and class 0 data is equal to the MP random rand n with the parameters of 102, which means that we have 2 input data in here. Okay, and so this is assigned to the class 0. Okay, and class 1 data can be assigned with the MP random rand n, right? This one, but we can assign to the plus 3, which means that we generate the whole data in the upper level, and we can draw a splitting line by using these terms. Okay, this is why we need to add the 3. But in real case, you always or already have a data for this class. Okay, but in this case I need to generate that. Don't judge me about that. Okay, so labels should also be given in here. MP zeros, okay, 100, and also label 1 should be given in the in the zeros, right? 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 Or wrong? Wrong or right? This is true? And also we need to change this code with the ones, right? Because the 2 label should be different from each other. Okay, so we need to concatenate data and labels. Data can be stacked with the v stack function in here in a sequence as a vertically. Okay, and so we need to add this one, and we need to give the tuple values in here, like this one, class 0 data, class 1 data. This simple implementation of the 1 data is adding to the another one in a vertical way. Okay, so all the labels can be assigned with the horizontal stack in here, but again the label 0 and label 1, right? You get it? V vertical, H horizontal, which means that this data is a sequence, about that the sequence order, like this one, class 0, 1, class 1 data. But in the labels, this is the horizontal label 0 and label 1. This is the only difference between these 2 functions. What's the point of this? I need to show the utilization of the vertical stack and horizontal stack. You don't need to separate these things. I can also use the vertical stack in here, but in the lesson it's more convenient to see this code in a different way. Okay, that's the point of utilization of this code. You get it? Okay, so convert the data to tensor in Pytorch, right? And so the data should be assigned with the torch tensor with the data, and d type is equal to the torch float 32, right? And also we need to give the labels, like this one, labels, right? This is why we need to convert these terms, because we need to implement the Pytorch library. Is that right or wrong? What's your thought? No. This is right. Yeah, so we can assign the float value in here. Okay. So define neural network in here. Firstly, we need to give the what class binary classifier. This is my name. I can also define the Mehmet class, right? I can do that, but it's meaningless in this case. We should write all the modules in here with these parameters, and then def init should be defined in here. It's the constructor of the R methods, and so we should also give the super binary classifier and self function with what the base constructor, right? So firstly, we need to give the what the fully connected layer in here. Okay, fully connected one can be created with the what the NN linear 2 and 32. Why do we need to assign to 2 at raw values? Why is it equals to the 1 or 3 but 2? Yes, yes. And also we can give the fully connected layer 2 with the definition of what? NN linear 32, and we get the 1 output values, right? But what's the meaning of 32 and 32? In the first place, the output is assigned to 32, and after that the FC2 must be in the first row, should be equals to the what? The first last node, which means that this column values must be equal to this row value. Okay, do you understand that? Okay, so also we need to give the what? The sigmoid function body, NN sigmoid. Okay, this is the function for the what? The binary classification. We will get by the utilization of this term to what? 0 or 1, right? Simple. Okay, and after that we need to create the forward function in here, self forward. What's the meaning of the forward? Explain to me. What's the meaning of this? Yes, yes. This is why we need to create the forward function, because this forward function creates the neural network structure, right? We obtain the outputs by using the forward function, but we train the network by using the backward function, right? Okay. So we can assign to what? Self FC1 function with the input values, but we should give the x value in here. But we can also utilize the rel rectifier unit body or the function in order to what? Create the new x value, and after that can create the another x value, self FC2 x in here. So this is the first layer, and each layer possesses what? The relu function, activation function. And in the second place, self FC2x is calculated as a linear neuron and assigned to the x. After that, x is newly assigned to the what? The sigmoid x. This is the classifier, it's the output value. We can change the variable name in here, but we don't need to do that. This output generate this x, this output generate this x, this output generate this x. And after that, we need to return to the what? What? Yes, x, right? Okay. So create the model. Firstly, we need to use the model. We need to call the constructor of the binary classifier. Okay. After that, we need to define the loss and optimizer. Right. Criterion can be defined with the what? The NN BCE loss. What's the meaning of the BCE? Just guess that. The first term is the binary. Binary. Yes, yes, congratulations. Binary cross entropy, right? Because the binary cross entropy function is more useful to be used in the what? The classifier problem or classification problem, right? After that, the optimizer can be defined with what? The optim and SGD, okay? With the what? The model parameters, and also we need to give the what? The learning rates, right? 0.1, for example. So the training model can be built with what? Firstly, we need to give the number of epochs in here, 1 or 10,000. Okay. After that, for epoch in range of num epoch, like this one, we need to give the forward pass in here. And after that, we need to give the outputs with the definition of the what? The model with the input values of the what? Data, right? This generates the our total output of our binary classifier. After that, the loss should be calculated with what? The criterion function. With the what? The output, not view function minus 1. The view is utilized to what? To second or the two function or two rows turns into the what? The one-dimensional data. Okay? This view is utilized for these things. 2D function is assigned or converted into the what? The one dimension. Okay? And also we give the labels, right? Labels. Huh? Yes? Huh? But in the labels, we build the labels the horizontal stack, right? And it's the one data, one-dimensional data. But in this stack, we have the two different inputs. Okay? The row values is equal to the what? Column values is equal to the what? The 2. But in the labels is already one-dimensional data. We don't need to do that for the labels. Do you understand that? Do you understand? Okay. So, for the backpropagation algorithm, we need to what? Firstly, optimizer should be reset, right? 0 grad. And the loss should be what? Backwards. And after that, optimizer step should be next, right? And also epoch plus 1 percentage 100 must be equal to 0 in here, and so this print f epoch like this one. This epoch contains to the what? The epoch plus 1 divided by 2 what? Just say it. Yes. Loss can be assigned with the what? Loss item, right? Right? Or wrong? Just say it. Okay. Thank you. Okay, this is the training fuss. Do you get it? Do you understand everything? Okay. Okay. In order to visualize all the results, we need to create the PLT figure function in here. Fixed size is equal to the 8 and 6. And firstly, we need to plot data by using the PLT scatter function and data 0 and data 1, right? This is the two-dimensional data. And also C must be equals to the labels, and C map should be assigned PLT CM spectral. Okay, S30. This is the representation of the spectral information about the labeling data in here. Okay, so after that we can generate the meshing points. Meshing for decision boundary. Okay, x, x and y, y should be assigned with the MP mesh grid function in here. First the MP lin space assigned with 1, and the other term lin space should be created in here because we have the two dimension in here. And so data 0, 1 dot mean values in here minus 1. Okay, and also we need to give the data 0 values the max plus 1, and 200 terms should be given in here. Mean and max point is assigned, and so we can generate the decision boundaries, right? Just a simple idea. Also we should give the this term in here, but for this case the 1 should be plotting, right? Do you understand what we are doing now? So the grid tensor can be assigned with the torch tensor. Tensor is the basic type of the of the Pytorch. Okay, and so MP C XX ravel function and YY ravel function. What's the meaning of this ravel? This is the MP array to the to creating this tensor for the grid operation. Okay, and also we need to give the the type torch float 32. Okay, so Z is equal to the model grid tensor like this one, because the XX and YY is obtained the whole data coming from this term, and so this grid tensor is assigned to the model, and we can generate the labels in the two dimension. So detach, and also we need to convert to numpy, right? Right? Okay, and Z reshape with the XX shape, because these terms is given in the scatter form, not a line form. Okay, and so we should assign the whole data with the same shape on the figure. So, and after that plot the decision boundary in here. PLT contour. What's the meaning of contour? X, X, Y, Y, Z, and C map. It's the spectral information about some regions. For example, if we have the contour value, and then we can draw or the fill some points is the yellow, the another one is the what? Is the red. Okay. C map, PLTCM, and spectral. And alpha is equal to 0.8. PLT X label is assigned feature 1, feature 2, PLT title, binary classification with Pytorch, and also PLT show must be given. This is our code. After the training phase, we get the what? Two classes, right? One of them is the red, the other term is the purple, but the contour of this term like this one. Okay, these are contour. You get it? The utilization of the contour parameter in here, and the decision boundary obtained with the watermarks and mean values of these terms. And so this binary classification classify these patterns by using these terms, right? Do you understand what we are doing in here? Okay? 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 Okay. So, we take a break at 5 minutes, and after that we will continue with the other examples.